I see 2, I see 4, I see 6, I see 8, I see 10, I see 12, I see 16, I see 17 good-looking teenagers. I need you to please take out the handout from yesterday, the notes that we didn't finish yesterday. Thanks for being there for me. Okay, first 3 people that hold it up in the air, you get a lifesaver. 1, 2, 3, incoming Melissa. All right, so we are filming. We're filming, right? Okay, yes, we are filming. We gotta go fast. We have 31 minutes, and I want this to be a heavy practice day for you all, not a heavy day for me talking. I want you guys to get really good at these things. So right now, if I say find the derivative, or you read in the handout, it says find the slope of the tangent line. You have 2 different options about going and doing this. There are 2 different formulas that you're supposed to have. I need one of them. I need one of them. One of the formulas that you use. Janaea. Limit as. Oh. Yeah.
Is x approaches a.
Limit as x approaches a. F of x. Minus f of a. Over x minus a. And this is going to tell you, tan, say it with me, you know you want to. Tan. That's tan of x equals a. Hector, what is that actually telling you?
The slope at a specific point.
One more time, you said it beautifully.
The slope at a specific point.
This is telling you the slope at one specific point. It's a great formula. It works really well. You guys got a lot of practice with this yesterday. I've got the notes for you. Just have a seat, okay? Slope of the tangent line at one specific point, that's the formula. All is good. Nice. Solomon, it's over here. There's a second one. Second one. One.
You.
The limit as h approaches 0.
Limit as h approaches 0.
F parentheses x plus h.
F of x plus h.
Minus f of x.
Minus f of x.
Over h.
All over h. I think I like that. There you go. What is that really telling you, Hector?
This goes to the slope at all the points.
This is the slope. And I just called him Hector twice in a row, didn't I?
Yeah.
So sorry about that. No candy for you. Slope at all the points. And now all that I know as a teacher is that Hector knows both formulas and what they mean. Great. Good luck, Hector. Are we all okay? Good. Now, the notation here that I really want to see is that this is f prime of x. This is your derivative. This is slope of tangent line everywhere. This guy here we sometimes call f prime of a. Both options are good ones. I like using this one if you know, like, hey, I need derivative at one point. But if it says, like, in general or a formula, this second one is what's going to give you a function. Or if you want a formula, this other one is only ever going to give you a number. It's going to tell you exactly what the slope is versus getting a function for an answer. Are we okay?
Yeah.
So, Jasmine.
Oh, what if it gives you a number? Because I remember I did once, and it gave me like just a number, not a function.
Okay, right. So, wait, like on this next one?
Yeah, that one.
Okay, there are special cases. Okay, but let's say I do this. Tan at x equals -5 is equal to +6. Talk to your neighbor real quick. What does that mean? What is your conclusion? You've done the work.
Therefore.
Tan is equal to +6.
Therefore.
What would you write?
The graph is increasing at x is negative.
Jaylene, you feeling good about this one? Okay. Jaylene, you've got the floor. What's your conclusion? What are you going to write?
I said that. Can I come up with
Okay. So f of x, what's f of x doing?
It's
Is increasing at x equals -5, and we know it's increasing because the slope of the tangent line is positive. How many guys would have written that exact sentence? Life is good. And Jaylene, here you go. Don't let Abel take it from you. Okay. And Abel, it was a candy, and it looked like I was throwing a brick at you. No! All right. So at the end of class yesterday, I want to close out our notes here. We were going a little fast. Pacing's going to get better, I promise, as I figure out all you guys on what you need and who needs what. We started taking that general formula and applying it here with the square root of x. So f prime of x, limit as h approaches 0, f of x plus h minus f of x all over h. You've got this in your notes. I want to finish it off. F of x plus h is the square root of x plus h. F of x is the square root of x. All over h, we get 0 over 0. This is a problem. That's the indeterminate form. How many of you all are pretty sure you know how to finish this problem up? Okay, then for the next 2 minutes, finish it up. I don't want to hear from you. I mean, I love you all dearly. I don't want to hear from you. I want to talk to the folks who are like, I'm here and I really have no idea what to do next. Where are those folks? Thank you for the honesty. The only way I'm ever going to know. Okay. So if I'm at this point and I say, all right, limit as h approaches 0, square root of x plus h minus the square root of x all over h, my first thought might be, let me plug in, right? Let h be equal to 0. And if I do that, I'm going to get square root of x minus the square root of x over 0, which is 0 over 0, indeterminate form, no good. No good. So what? Sandra. Okay, so I hear you saying you're going to want to multiply by fancy 1. I agree. I need to hear the what that fancy 1 is. And the fancy 1 is
Conjugate.
the conjugate 1. What's the conjugate for this problem going to be?
Square root of x plus h
Square root of x plus h
plus x plus square root of x
plus the square root of x.
over square root of x plus h plus square root of x.
Okay, love it. And that is fancy.